The reason I wanted to start back a little bit early is we have two people from Southern California have to catch a flight. So I want to gain a little time actually. So I think there's been a lot of interest in the field study, and that's the next section. And let's see if we can find where that is in the book. I think it's 4. Yes. And as usual, Patty's going to give us an overview and then turn it over to Rebecca. Oh, and apparently some of the people listening remotely have had trouble hearing all the comments. I think that also refers to the presenters. So if we can remember to speak right into our mics, that would be good.
Okay. This is on your binder, section number 4, and title is Field Study. In this topic, we'll discuss two main sections, two main topics. First, Ms. Rebecca Beloso will describe the field selection process, and then Dr. Randy Medellina will come in and present the details about the field setup and sampling method. Again, overview. We are approaching the field study in a stepwise method. We separated in 3 different phases. We have complete phase 1, which provide uninstalled material from the recycler facility and also from 4 fields in California, limited sampling. Basically, the crumb rubber sample in this area is for method development, chemical analysis in the lab. Total of 4, 2 come from Northern California, 2 come from South. And within each region, we sample a young field and an old field. And we only sample crumb rubber, and there's no field activity. That means no human activity other than resampling. Phase 2, we are in the middle of the process, mainly is to validate our sampling protocol and fine-tune the method and equipment. We plan to sample 2 fields, one in Northern Cal, one from Southern Cal. In the Northern Cal, we are going to sample a younger field. In the Southern Cal will be an older field, mainly to iron out how we should sample the logistic. And on the field, we are sampling crumb rubber, chemical vapor, as well as particle, the airborne particle. And there will be, and there has been, limited field agitation, means our field crew actually kicking the ball around with help of some equipment to stir up some agitation. And then in the phase 3, which we hope to start very soon after we finish ironing out all the method, is to collect field throughout California. We are aiming to collect more than 20 fields throughout California. And we are going to separate the field in 2 groups, one young, one old. Further detail will be described in Rebecca Beloso's presentation. We'll sample crumb rubber, chemical vapor, as well as airborne particle. And on this one, we will have scripted human activity, trying to mimic like practice or game during the use of the field. And it will be a more extensive agitation of the surface and to provide a real active field situation during the sampling. Oops. Okay. This diagram shows the timeline. As I said, the first phase is completed. The second phase, originally we were hoping to complete by now, but unfortunately you probably know about the rain in California. The equipment is not rain-proof, so we are in the middle of it, and hopefully we'll finish it fairly soon, and then we'll start our third phase of the full-scale sampling towards this year and finishing early next year. Just want to give you some idea what we do in the field. This is a picture when we went out, a typical soccer field, synthetic turf field, and we'll go in, label the area before we sample. This is our phase 1, only crumb rubber. We label, set the boundaries, set down there, collect enough crumb rubber, and we send it to the lab. Okay. Now I'm going to pass on to Ms. Rebecca Peloso from OEHHA. She will describe the field selection process.
Thank you very much. Okay, so in order to provide a comprehensive analysis, we will cover different parameters for the overall picture of exposure in California. In sampling our phase 3 field study, we have proposed to use a stratified random sampling method for field selection. We will get into more detail regarding this method in later slides. Okay, our selection criteria consists of 3 factors. First, climate zone and temperature. We are looking into these factors due to the weathering on crumb rubber. Our second criteria is age of field. We are looking into younger fields because they tend to release volatile chemicals. And we are looking into older fields because the weathering tends to release fine particles. Our third criteria is looking into atmospheric ozone level. So we are looking into high and low ozone levels because ozone tends to break down rubber. Okay, sorry about that. So California is broken up into 16 climate zones according to the California Energy Commission. This is a map that shows where all 16 climate zones are located, and we have included a table with the different counties throughout California. So we have proposed grouping climate zones together by warm season temperatures, and we have come up with 5 different climate regions. The first region consists of southern coastal areas, and on the map it will show up in red. It's mainly Southern California. Our second region consists of northern and central coastal areas. That is on orange in the map. The third region is southern interior valleys and northern central valley. That's shown in yellow. Region 4 is southern high and low deserts, which is shown in the light green, and 5 contains mountainous areas in dark green. The top 3 regions contain a high number of fields, whereas the 4th and 5th groups contain a small number of fields, and we have taken this into account when we propose our field selection. This is our overall field age distribution according to the data of 905 fields that we have collected from CalRecycle. Graph A shows the age distribution of all fields in California. Most fields are in the range of 3 to 14 years old. Graph B is a cumulative distribution of all field ages, and this shows about half of the fields are 9 years or younger. Therefore, we have decided to divide each climate region into 2 groups, a young group consisting of ages 0 to 8, and an older group consisting of ages 9 and up. Additionally, since the warranty of synthetic turf fields ends at 8 years, we believe that this will also be a good cutoff point so that we can determine exposure of older fields that are no longer under warranty. This shows our regional field age distribution. For regions 1, 2, and 3, you can see that many fields are available over a variety of ages. However, regions 4 and 5 show fewer fields available overall. Region 4 has very little fields in the younger age group, and Region 5 has fewer fields in the older age group. We have broken down the total number of fields into various subgroups. First, we have two types of climate regions. There are 3 climate regions with a high number of field and 2 with a low number of field. If you look at the left of this diagram, you will see that we have broken down fields by age and ozone levels according to each age group. And we have done the same on the right side with low density field areas. The data that we have collected for high ozone and low ozone levels is based on the data from Cal EnviroScreen 2.0, and we have cut off at the 50th percentile. We propose to perform a stratified random sampling method within each climate region. From regions with a high number of fields, we will choose 2 fields to sample in each strata as highlighted in the red cells. From regions with low number of fields, we plan to choose 1 field to sample in each strata, as highlighted on the red cells. Therefore, we will generate a random list of fields in each region and contact each field in random order. If a field decides not to participate, we will move on to the next field in the random order so as to avoid bias. Some categories have 0 fields or only 1 field available. As a practical approach in regards to our resources and time constraints of this project, we propose not sampling from strata with 0 or 1 field. Hence, we see that Climate Region 1, the southern coastal area, will have 8 fields sampled total. And Climate Region 2, northern and central coastal areas, will have 4 field sample total, 2 from each strata. Next, we will see Climate Region 3, southern interior valleys and northern central valley will have 8 field sample total, 2 from each strata. And Climate Region 4, southern high and low deserts will have 2 field sample total, 1 from each strata. In Climate Region 5, mountainous area will have a total of only 1 field sampled. So taking into account that we will not be sampling strata containing 1 or 0 fields, our proposed plan consists of sampling a total of 23 fields. Thank you.
Thank you, Rebecca. So my usual first line for each section. Does the panel have any general comments about this field sampling strategy? Go ahead, Dr. Eckel.
Hey, so as a statistician, I really enjoy that you've tried to take an approach where you identify some important factors and try to do that random sampling within these factors. So I think that's a very strong approach. And I would like to get a little bit more specific if that's okay.
It's okay.
Okay, so I assume that by stratifying on these various factors that you might eventually be interested in looking at differences by some of these factors. For example, you might be interested in differences by region or differences by high, low ozone and so on. And I know that you have constrained resources. You want to sample between 20 to 25 fields, I had read. And so I do have some concerns that you have 5 different regions, and that's a lot of regions. And in your sampling design, you have 2 different ozone categories, 2 different age categories, and 5 region categories. So that gives you 20 cells. And you're trying to sample, 20 to 25 fields of those 20 sort of cells in your sampling design. So that is, you're trying to do a lot. So I have concerns about, especially regions 4 and 5 having, only 2 or 1 field respectively. You're going to have a very hard time partitioning out differences between, fields or regions 4 and 5 and the other regions as well. So I understand that there's probably a desire to be representative of all of California. So, a couple options are that maybe you could collapse regions 4 and 5. Or potentially drop them if you're okay with not having that representativeness. Otherwise it might be nice to increase region 5 to have at least 2 fields rather than only 1 field because it's nice to have at least one replicate. That would be great. And then my other comment was that for region 2 where there's only 4 fields because there was just the low ozone, I believe it was. So you sampled only 2 fields in the young and the old. fields both in the low ozone strata. If it would be possible to maybe oversample a little bit to get maybe 6 fields in region 2 rather than only 4, that would help you better characterize the differences, again, across regions, if that is a very important factor for you.
Just one comment about potentially collapsing regions 4 and 5. They have strikingly different climates, so I don't think that would be a good thing to do. I understand why you suggested it statistically, but yeah, because one is mountainous and the other is desert, right? So I think, your point is well taken about, a lot of strata for a relatively small number of fields. Dr. Sheldon?
So I was just looking at the results of the EPA study, and they were getting 40 fields, and I'm not even sure they were doing the full monitoring set on. They got 19 from the U.S. Army, so then there were 21 other fields that they needed to get. They had to contact 309 fields to get the 21. That being said, it's going to be very difficult to recruit the fields, and I guess my question is that this may have to be catch as catch can. Are there things that you absolutely have to stratify on? I mean, just the idea that it's going to be so hard to find, I think, to find fields, unless you're much better, it is going to be a problem. And so I do think you need to think about that.
So just a sort of a follow-up question. So you've done some pilot work. How hard was it to get those fields?
I'm going to respond to it. Rebecca has been helping us to recruit, so she experienced a lot. In the initial, when we first did the first pilot study, we did encounter a lot of difficulty on recruiting field. And since then, we have changed our protocol, and we see an improvement in recruitment. There's certain areas are really willing to participate, and there's some individual didn't want to talk to us at all. So that's a reason, one reason that why if there's one field in the whole region, chances of getting it may be slim. We don't know until we call them. And our approach is we're going to call until we find a field. And we have been doing it. Lately, it's been improved. So we're going to see how it goes as we work with our lab, work with internal OEHHA. We've been talking with US EPA and see how we can engage the community. And I think with more study rolling out, like the observation study, people is going to want to know, learn about the study. So hopefully it will improve the recruitment.
And I want to add that we hear you, and it's our concern as well. There are many ways to stratify this, but we also understand there's interest in all these variables. So it's very difficult for us to say this factor we would not look at. And it's a very difficult situation because, yeah. And if we can get any suggestion from the panel to collapse some of these stratification, that would be great.
Dr. Kyle.
I'm wondering whether your regions are really, it seems like proxies for climate, right? So that's temperature and heat. I mean, temperature and water, rain.
And ozone.
Well, ozone is separate. And so I'm wondering whether you could just treat those as continuous variables, and then you would be able to analyze things across both multiple dimensions for all the fields, and you wouldn't be stuck with all these cells. So that would be my suggestion, probably being the worst statistician up here.
Help us out.
I guess, for climate, there is more than just the hottest temperature in summer. There are other considerations.
When I analyze the data, we actually look at the representative city with data available. We analyze the highest average temperature in the hot summer and also the average temperature during the summertime. And also when we look at regionally, we look at whether it rain, whether it snow. That's why the mountain area wasn't grouped with the high desert, because the mountain do snow. Yep, and it is more humid, while the hot desert is dry and hot and extreme. And the Central Valley is more heat related, and being wind also, the humidity we look at, kind of average it out. And the coastal area, we have less ozone in the northern California, being windy, humid, while it's different from the southern coastal area being warm and breezy, humid. That's why we separate the coastal region in two different. We try to make it as little region as possible so we can sample within more. And this is how we can see average. So if some of the region, like the one with 2 field, we cannot recruit, we probably have extra field we can sample in the high density area, in Bay Area, in LA area. So that's something that's become more flexible as we recruit.
Dr. Bennett.
I just had a little question on the age distribution. It looks like there's no really new fields. There's very few 2-year-old, none 1-year-old. Is that just because you collected the sample of fields a couple years ago and now they're older, or are there just not any being installed in the last couple years?
Based on the data we get from CalRecycle, we had just updated in the early beginning of the year. So we get constantly getting data from them. So when we get more data, we will update. But this is what we get from, I would say, January 2017. So it's up to date as we can. We don't know why, because we don't involve in building field. I don't want to offer any explanation here because I don't know. But we can see that there was a high peak around the 6 to 10 years old. Water may be an issue, or maybe when they first come out. I don't know.
Dr. Sheldon.
So I will find you the reference. I was reading it this morning, but what I read was that a number of these fields, they recommend that you replace the infill every 8 years. And if that's the case, I think you need data for what it looks like in California and what actually happens on the fields, because they may all be within a 10-year-old age if you look at infill. But I'll try to find out what I was reading when I saw that.
Maybe I can give you a little bit what we have found. It may not apply throughout California. In a preliminary pilot study, when we go out, we did a survey, we interviewed the owner. Have you replaced the field? Have you patched it? Have you add crumb rubber? Whether the crumb rubber was come from the original stock versus was it new purchase? So we have surveyed before we go in. So far, the old field we sample has never been replenished. And it's more than 10 years. I'm not saying that it represents, but when they say if we have replaced it, we will be more cautious about sampling in the area they have replaced, maybe not selecting a field that they have replenished. We did have field that more than 10 years old that have not been replenished, and it looked really bad. Hope they keep it.
Go ahead.
It sounds like there's the potential that if you get lucky, there might be an interesting sort of natural experiment that you could see. If some of these older fields, they are thinking about replenishing them, that would be an interesting, to look at the field before and after the replacement, because everything else could be held constant essentially, and you'd have that sort of the new age versus the older age. So if you encounter that, that would be neat.
Ed.
Is there an internal quality assurance aspect to this? Are you duplicating some sampling at a field, or holding back 10% or anything like that, or just everything is unique, one field at a time, and don't look back?
Trying to understand the question here. We go in and we sample field and collect individual sample on the field, and we ship it to lab, and sitting in the lab now, we're trying to figure out the method first. So the field sample has not been, we haven't get to the point is actually doing field study. We're setting up for the method.
You go to a field, you sample in the 4 different locations or whatever it is, and then you homogenize that, that's one field.
We get 10 sample per field, and we ship it as 10 individual sample location, and each one has sample from organic and for inorganic in separate different whole container.
I think we're going to hear more about the field sampling methods.
I guess that decision has not been made whether to composite the samples or how many spots on each field we will sample.
So taking a step back, I mean, I think you're obviously trying to be very democratic and representative and, try to cover all the bases. And as Dr. Eckel pointed out, that's going to be impossible statistically given the financial limitations of what you want to be able to do. So I think you need to sort of make a decision about what the priority issue is. And based on the discussion we've had, I think part of the issue is ozone, non-ozone, and potentially age of field. And for other guidance, you might get some input from the laboratory about, what the conditions are in which you get maximal volatilization or maximal production. But I don't think you're going to be able to sample based on climate variability.
At least not at the level of 5 different climates.
Yeah, not
Climate categories.
with a total of 20 fields or so forth, and get anything that you can then generalize from.